Hi children, we continue with our class. Today's chapter is chapter 4, materials, metals and non-metals. In the last class, we started the chemical properties of metals and non-metals, and under that we discussed how metals and non-metals react with oxygen. Now there are more reactions left that we will see. Now the second reaction, today we will see the second reaction with water. How metals react with water. So metals react with water to form metal hydroxide and hydrogen gas. So we can say that metals react with water to form metal hydroxide and hydrogen gas. I hope you remember the reactivity series in which metals are arranged in the decreasing order of their reactivity. Which metal is on the top of the series? Potassium followed by sodium. Sodium is a highly reactive metal. So we will write the example with sodium. Sodium is a highly reactive metal. So it reacts vigorously with water. What do you mean by a vigorous reaction? A very violent reaction takes place. Since sodium is highly reactive, it reacts vigorously with water to form sodium hydroxide and hydrogen gas. Hydrogen is a highly inflammable gas. So the reaction of sodium with water is highly vigorous or violent. A lot of heat is produced in this reaction, and because of this extremely high amount of heat energy, the evolved hydrogen gas catches fire. That is the reason why we say that this reaction is vigorous or violent. So sodium is a highly reactive metal, so it reacts vigorously with water to form sodium hydroxide and hydrogen gas. A lot of heat is evolved in this reaction. Because of this, the evolved hydrogen gas catches fire. So a very vigorous or a violent reaction for a highly reactive metal like sodium. Now when you move down the series, this series you have to learn by heart. Potassium, sodium, calcium, magnesium, aluminium, zinc, lead, zinc, iron. What happens to iron? Iron reactivity is moderate. Its position is somewhere in the middle of the series, so it is moderately reactive. So it reacts slowly with water. Reaction of iron with water is very slow because its reactivity is also less compared to that of sodium. Now towards the end of the series, towards the bottom of the series, you can see metals like silver and gold. They are least reactive metals. They do not react with water. No reaction with water. Okay, so we can predict their reactivity, reaction with water, the rate with which they react with water based on the reactivity series. Highly reactive metals have vigorous or violent reaction. As you move down the series, reactivity decreases, rate of reaction decreases, and metals like iron will react slowly with water, whereas towards the end of the series, gold, silver, etc., they do not react with water. So that is about reaction of metals with water. Metals react with water to form metal hydroxide and hydrogen gas. An example is sodium, highly reactive metal reacting vigorously with water, resulting in the formation of sodium hydroxide and hydrogen gas. Okay, vigorous reaction because a lot of heat is evolved, and because of this high amount of heat energy, the evolved hydrogen gas catches fire. Metals like iron, which is moderately reactive, the reaction is very slowly they react with water, and less reactive metals like gold and silver, they do not react with water at all. Okay. Now metals like, there is a question, sodium and potassium are stored in kerosene. What is kerosene? Mannanna. Give reason. Now the reason may be clear to you now. Sodium and potassium are highly reactive metals. highly reactive metals. They react vigorously with both air and water. They have a very vigorous, violent reaction with both air and water. If they come in contact with atmospheric air, they catches fire. Vigorous reaction with water also. A lot of heat is evolved in this reaction. So, to prevent the contact of these metals with air and water and to prevent accidental fires, these metals are stored in kerosene. So, this is an important question. Why sodium and potassium are kept in kerosene, stored under kerosene? These two metals are highly reactive. They have a very violent reaction with both air and water, and in both these reactions a large amount of heat energy is liberated. So, to prevent the contact of these metals with air and water and also to avoid accidental fires, these metals are stored in kerosene. Okay. Now, how metals react with how non-metals react with water. So, we saw how metals react with water. Non-metals, they do not react with water. Non-metals have no reaction with water. So, now it is easy. You have to learn only metals, how metals react with water. Non-metals have no reaction with water. Under this, there is a question. Phosphorus is stored in water. Give reason. So, phosphorus is a highly reactive non-metal. Phosphorus is one of the highly reactive non-metals and it catches fire when it is exposed to atmospheric air. Phosphorus catches fire when it comes in contact with atmospheric air. So, to prevent the contact of this non-metal with atmospheric oxygen, it is kept in water. So, generally non-metals do not react with water. Phosphorus is a highly reactive non-metal. When it comes in contact with air, it catches fire. So, to prevent its contact with air, it is kept in water. With water, it has no reaction. So, it is stored in water. Phosphorus is stored in water. Sodium and potassium, they are metals, they are stored in kerosene. Okay. So, metals react, they form hydroxide and hydrogen. Non-metals, no reaction. I hope it is clear to you. Now, we move on to the third reaction. Reaction with acids. A. Metals. How metals react with acids? How metals react with acids? So, a metal react with acid to form metal salt and hydrogen. So, a metal reacts with acid to form metal salt and hydrogen gas. For example, a metal zinc reacts with an acid sulfuric acid. The salt produced here is zinc sulfate plus hydrogen. So, this is how we write the name of the salt. Name of the metal should be written first, then the second part comes from the acid. If the acid is hydrochloric acid, we will write as chloride. If the acid is sulfuric acid, we will write as sulfate. If it is nitric acid, we will write as nitrate. Now, you do not have much to learn, just learn this example. Naming the salt is important. First, write the name of the metal which is used in the reaction. Second part is from acid. Since it is sulfuric acid, we write here as sulfate. If it is hydrochloric acid, you should write chloride. If it is nitric acid, you will write as nitrate. Okay. So, this is an example. Zinc reacts with sulfuric acid to form zinc sulfate. That is the metal salt there. Then hydrogen gas. Now, there is a test for hydrogen gas. Hydrogen is a colorless, odorless gas. Hydrogen comes out as bubbles. You can see the evolution of bubbles, but the gas is colorless and odorless. It has no color, it has no smell. So, how to identify whether the given evolved gas is hydrogen or not? For that, bring a burning candle. Bring a burning candle or matchstick near the mouth of the test tube. Near the mouth of the test tube. Bring a burning candle or a matchstick near the mouth of the test tube from which the gas is evolving. If the evolved gas is hydrogen, it burns with a blue flame. The gas, not the flame of the matchstick, the gas will burn. Gas burns with a blue flame producing a pop sound. So, pop, a sound will be there, pop. So, that is the test for hydrogen gas. Bring a burning candle. So, from the test tube, a gas is coming out as bubbles. It has no color, no smell. So, we want to test whether it is hydrogen or not. So, bring a burning candle or a matchstick near the mouth of the test tube. If it is hydrogen, the gas will burn with a blue flame producing a pop sound. So, that is the test for hydrogen gas. So, metals react with acids to form metal salt and hydrogen gas. For example, a metal zinc reacts with sulfuric acid to form the salt zinc sulfate and hydrogen. Now, test for hydrogen is very important. Bring a burning candle or a matchstick near the mouth of the test tube. The gas burns with a blue flame and a pop sound. We can confirm the evolution of hydrogen. Now, how non-metals react with acids. Non-metals, no reaction with, non-metals have no reaction with acids. Non-metals do not react with acids. Okay. So, metals react for metal salt and hydrogen. Test for hydrogen you have to learn. Non-metals have no reaction with acids. So, that is all. Thank you children.